Good evening, everyone. Today we'll be discussing some 20 image-based MCQs from dental histology. Are you all able to see me? Uh, Am I audible? So let's begin with the first question. So let's begin with the first question. And the question is identify the tissue or structure marked by the arrow. So you can see a diagram here, right, which represents a histologic section of some portion of the oral mucosa, right, and you have to identify the structure which is marked by the arrow. So let's first identify the tissue that has been shown in this picture, right? So what you can see in this picture, you can see that some hemidesmosome like structures are shown here, right? This is a hemidesmosomal structure, right? Then you can see two compartments that can be seen here. So maybe they represent cells, and these hemidesmosomal attachments can be seen here clearly, right? Then you see two layers here, and then we have some fibers, right? So some fibers are arranged in the form of a loop, right? Some fibers are arranged in the form of a loop, and several other fibers are looping through them. So these are several other fibers which are looping through, isn't it? So maybe this represents the histological section of a oral mucosa, right? So let's go to the options. Maybe that will help you more, right? So the options are anchoring fibrils, type 4 collagen, type 1 collagen, and type 3 collagen, right? So look at the arrow. What does the arrow mark here? So let me delete these markings. So as you can see, the arrow is pointing towards this looping structure, isn't it? It's pointing towards this loop, isn't it? So what do you think this loop represents? What do you think this loop represents? Which tissue does this loop represent? So we all know that the type 4 collagen, which is in the chicken mesh pattern, is found in the lamina densa, right? So this is the lamina densa, and type 4 collagen is found within the lamina densa. Then the anchoring fibrils or the type 7 collagen, right? Type 7 collagen or the anchoring fibrils, they interlock with the type 4 collagen and help connect with the connective tissue. So these two fibers are the type 1 and type 3 fibers, while the answer to this question would be anchoring fibrils, right? So the answer is anchoring fibrils, isn't it? Is it clear, everyone? Can we move to the next question? So let's go to the next question. Identify the landmark in the circle. So as you can see, this is a picture of a bone, isn't it? This is the picture of a bone. और आप इसे ध्यान से देखोगे तो आपको समझ में आएगा that this is the picture of a condyle, right? This is the picture of a condyle. और इस कॉन्डाइल में हमने क्या पूछा है, यू हैव टू आइडेंटिफाई द लैंडमार्क दैट इज मार्क्ड इन द सर्कल। तो कॉन्डाइल दिख रहा है हमें, लैंडमार्क आइडेंटिफाई करना है। लेट्स गो टू द ऑप्शंस, medial pole, lateral pole, anterior pole, and the posterior pole. So look at this diagram clearly and recall what we have studied in the class. Which pole of the condyle is more prominent or is the most prominent, right? So we have studied in the class that the medial pole is the most prominent pole of the condyle, isn't it? So you can see here that this pole, the one marked in this circle, is quite prominent, isn't it, as compared to the other side. So the one marked in the diagram is medial pole. Clear hai? It is the medial pole, and right below it you can identify the pterygoid fovea. So pterygoid fovea is the site of attachment of the lateral pterygoid muscle, right? This is the site for attachment of lateral pterygoid, and the medial pole is the most prominent one. So if you are asked which side has greater articular surface, which side of the condyle shows greater articular surface, is it the anterior part or is it the posterior part, right? So here we can see the anterior view, we don't see the posterior view in this diagram, right? So if the question is which side has greater articular surface. So if you are asked about the greater articular surface, then the answer would be posterior side. So on the posterior side, it occupies more of the articular surface. Clear hai? So this is the second question. I hope it is clear. If you have any doubt, you can ask me. So can we go on to the next question? Can we go on to the next question? So the next question is that you have to identify the difference between the two images below, right? You have to identify the difference between the two images below. So if you are not really sure about what these images represent, maybe you should read the options. So whenever you are in doubt after the question, looking at the images, maybe options will help you. So look at the options. Option A is enamel and dentine. So option A is probably enamel, option B is probably dentine. Option B says that A is dentine, B is enamel. Option C says A is pattern 3 enamel while B is pattern 1 enamel. Option D says that A is pattern 1 enamel while B is pattern 3 enamel, right? Now, look at these diagrams. Do you think that any of these two represents dentine? Dentine should have dentinal tubules, right? Dentine should have dentinal tubules. That is the characteristic feature of dentine, isn't it? So if there is dentine, then there has to be dentinal tubule. Now looking at this diagram, though circular structures can be seen or circular markings can be seen, but they are occluded, isn't it? It appears like a solid surface. There are no tubules, isn't it? They are just circles, but there are no tubules. So even this tissue cannot be called a dentine, isn't it? So this tissue is not dentine. So we end up with enamel, right? Both of these are enamel. So the difference between these two, that means we have to choose from either of the two options, that is C and D, right? So we have studied in the class that there are three enamel patterns, pattern 1, pattern 2 and pattern 3. In pattern 1, there are just head of the rods, isn't it? Head of the enamel rods is seen randomly oriented in the tissue, isn't it? If you take a section of the enamel, you will just see the enamel, you will just see the head of the enamel rod. There is no tail region visible here, isn't it? So this can be said to be pattern 1 enamel. While what happens in pattern 2? In pattern 2, you will see both head and tail, and they will all be aligned in a line, isn't it? They will all be aligned in a line. So head and tail, then again head and tail, they are all aligned in a single line, isn't it? But in a pattern 3 enamel, that is this one. In a pattern 3 enamel, what happens is heads and tails are alternately aligned. So you have this typical keyhole feature here. Right? So you have the alternate arrangement of head and tail region of the enamel round. So you can see this is the tail region, then the head region, then again tail, then again head. So alternate arrangement of head and tail region is seen in type 3 enamel. And the same arrangement you can see in this first diagram. This is the head, and in between you can see this tail. Then again head, then again tail. Isn't it? So this is the alternate arrangement. So in these two diagrams, we see type 3 enamel and type 1 enamel. Type 3 is this first diagram and type 1 is the second diagram. So option C is your answer. Is it clear? And also type 3 enamel pattern is the most common pattern found in the human dentition. Right? It is the most common pattern found in the human dentition. Next, we must identify the characteristic feature that is seen in the ground section of the tooth. Right? So this is the ground section. And we must identify the characteristic feature that is seen in this section. Right? आप लोग फॉलो कर पा रहे हैं? Are you guys able to understand? क्या ये MCQ समझ में आ रहे हैं आपको? कोई डाउट तो नहीं किसी को? So let's look at the options. Enamel rods, enamel lamellae, Hunter-Schrager bands, and gnarled enamel. Right? So we must identify the characteristic feature that is displayed in this ground section. Right? So take a look at this ground section. We can see two different types of tissue here, isn't it? We can see two different types of tissue. This is the first tissue and this is the second tissue, isn't it? And look at the shape of this second tissue, isn't it? It appears almost like a triangle, isn't it? So probably this section is taken from a cusp region, isn't it? This section is probably taken from a cusp region. And what characteristic feature is seen in a cusp region? Now maybe some of you would say that enamel lamella is seen here, right? And so many enamel rods are also seen here, right? And probably some of you might confuse these dark and light zones with Hunter-Schrager bands. But Hunter and Schrager bands we have studied, they extend till the outer 4/5, right? They extend for the inner 4/5. Only in the outer 1/5 they are absent, isn't it? So Hunter-Schrager bands are not seen only in the outer 1/5. In the entire inner 4/5 they are seen. But here they are seen only for a short distance close to the dentino-enamel junction. So they can't be Hunter-Schrager bands. And obviously we are not given any information about the lighting in which they are observed, isn't it? So Hunter-Schrager bands is ruled out. But what about the rest three? What about the rest three? Enamel rods can be seen. Enamel lamella can be seen. And obviously since it's a section from cusp, gnarled enamel has to be there, isn't it? Now the question is talking about the characteristic feature, isn't it? It is talking about the characteristic feature, a unique feature, isn't it? So a unique feature that is seen only on the cusp is gnarled enamel, isn't it? It is the gnarled enamel. Clear? And hence the answer to this question would be option D, that is gnarled enamel. You can see here that the enamel rods are all curved, right? They are all curved, they are bending, right? And they are forming a sort of a knot-like structure here. They are forming a sort of a knot-like structure here. And hence the name gnarled enamel, isn't it? Hence the name gnarled enamel. Now enamel rod would be seen in any section of enamel, isn't it? And same is with enamel lamella. It can be seen anywhere on the enamel. It can be seen in any section of the enamel. But gnarled enamel is specifically seen in enamel, is specifically seen at the cusp region, isn't it? And hence this is our preferred answer. Is it clear? तो आगे बढ़ते हैं। आई होप आप सबको समझ में आ रहा है। Let's go to the next question. We have to identify the difference between the two ground sections that are seen in this picture, right? So this is the image A and this is the image B. And let's go to the options. There is no difference. Option 1 says there is no difference, and they both represent striae of radius. They both show the striae of radius. Whereas in option B, it says that A is longitudinal section and B is cross section. A shows striae of radius while B is showing the cross striations. Option C says the opposite of option B, right? A is cross striation, B is striae of radius. And option D says that B shows pulp, which is absent in diagram A, right? So let's go to these diagrams. Now you can see a scalloped junction between this outer tissue and the inner tissue, right? So definitely there is no scalloped pulpal surface, isn't it? So scalloped surface represents the dentino-enamel junction. So obviously option D is ruled out. There is no pulp in any of these ground sections, right? It's just the hard tissue. Obviously it's a ground section, soft tissue is lost. Only the hard tissue is remaining. So we are seeing basically enamel and dentine in these two diagrams. And as we have studied in the class, enamel moves from DEJ towards, enamel is laid down from DEJ towards outer surface, and cross striations are parallel to the direction, or you can say they are perpendicular to the enamel rod, right? They are perpendicular to the enamel rod. Whereas striae of radius, they represent the incremental formation over a week's duration, isn't it? So more of enamel is formed towards the cusp and less of enamel is formed towards the cervical portion, isn't it? And hence we get an oblique line, right? More of enamel is formed towards the occlusal part. Let's say this is the occlusal part, this is the part where the cemento-enamel junction is formed. So more of enamel has formed towards the occlusal side, less of enamel in the same time has formed towards the cervical region, and hence an oblique line would form. An oblique line would form, and this represents the striae of radius. And when you see the same striae of radius in a cross section, they would appear circular, right? They would appear circular around the dentine, isn't it? So in both these diagrams, the structure that is seen or the feature that is seen is the striae of radius. So option A would be the best choice. Now, though it says there is no difference, we know that first shows an longitudinal section and the second one is a cross section. But apart from these sections, there is no difference, right? They both are representing striae of radius. You can see the focus of these histological diagrams, right? The focus is on striae of radius. So even if you are thinking that the options are wrong, you can still say that option A is least wrong amongst all the other options. And always remember that answering an MCQ is never about finding the right answer. It is about finding the best option, right? So if all the options are wrong, you have to find which one is least, which one is most correct, right? If all the options are correct, you have to find which is the most correct or most applicable to the question in that moment, right? So let's go to the next question. Question 6. Identify the feature in the circle below. So you can see some dark bands here, right? And also we can see an enamel lamellae, isn't it? So which of these two would you go with? Options are Hunter-Steger bands, enamel lamellae, enamel caries, and none of the above. So we have a sure shot finding here that this is enamel lamellae, and then we have this dark and light tissue that is seen in this round sector. So can it be said that this is Hunter-Steger band? Can we identify this as Hunter-Steger band? The answer would be no, since Hunter-Steger bands are seen on the inner 4/5 region, isn't it? It is seen on the inner 4/5 region, not in the outer 1/5 region. So definitely this is not Hunter-Steger's band. So Hunter-Steger's band is ruled out. Enamel lamella is crossed. So what is it? It is actually enamel caries, right? This is enamel caries. The caries which is confined only in enamels. The demineralization is progressing from the surface towards the DEJ, right? And hence the appearance. So let's go to the next question. Identify the unique features seen in the ground section below. So you can see a ground section of a tooth. It is the cross section of a tooth, and you can see white area and a relatively translucent area here, right? So we can see two different zones on this same tooth, isn't it? And the options are sclerotic dentine, dead tracts, secondary dentine, and tertiary dentine, right? So the unique feature that we can see here is this butterfly shape, isn't it? You can appreciate this butterfly shape, right? So this characteristic or this unique feature is formed due to deposition of the or due to formation of the sclerotic dentine, right? It is formed due to formation of the sclerotic dentine. And if anyone asks you where is the sclerotic dentine typically formed, it is formed typically on the proximal sides of the roots, right? It is formed on the proximal sides of the root, right? It forms on the proximal side. So this is the typical location for the formation of sclerotic dentine. And since this is the physiological dentine form, unlike the sclerotic dentine that forms in the crown, there it forms in response to injury, isn't it? And here it is forming as a physiologic response. So more commonly or technologically, the correct term for this sclerotic dentine here would be simply translucent dentine, right? So we can also call it translucent dentine since it is the physiologically formed dentine. But the same translucent dentine, when it forms in crown because of some chronic trauma, then it will be called specifically sclerotic dentine. So let's go to the next question. Question number 8. Identify the feature seen in the ground section below. Again, we are represented with the ground section, and we can see some black. You can see some black discoloration here, right? Some these black discoloration, and then we have this tubular arrangement, isn't it? We have these tubular arrangement. On the outside, we also see cementum, right? So this becomes dentine, isn't it? Look at this junction, it does not appear scalloped, isn't it? It does not appear scalloped. The typical scalloping between enamel and dentine is absent, and hence the outer tissue is cementum and the inner tissue is dentine, right? Now looking at this dentine just beneath the surface, the surface dentine is mental dentine, right? It is the mental dentine. Just beneath is the circumpulpal dentine, isn't it? Here we can see some defects, right? Here we can see some defects within the dentine. And as we have studied in the class, in the circumpulpal dentine, the most common defect that occurs is this interglobular dentine, isn't it? Interglobular dentine. And why does this interglobular dentine form? It forms because there is a failure of the fusion of the calcospheroids, isn't it? There is a failure of the fusion of dentine calcospheroid. So dentine forms in a spherical manner, isn't it? The mineralization front of dentine is spherical, isn't it? So these spheres, they grow eventually, isn't it? So when they fail to fuse, the interglobular space remains unmineralized. So this black region represents the unmineralized, right? It represents the unmineralized zone, and since it forms between the globules, it is called interglobular dentine, right? So let's go to the next question. Question number 9. Identify the predentine in the histological diagram. So we know that the sequence of formation of dentine is from the pulp. Let's say this is the pulp, right? So on the pulp, odontoblasts are arranged at the outer surface, isn't it? So these odontoblasts will first deposit the organic matrix or the pre-dentine, and as the odontoblasts move pulpward, this outer layer matures, isn't it? This outer layer matures and it will become mineralized. So always the outermost layer is mineralized and the layer just adjacent to the pulp is unmineralized, right? This layer adjacent to the pulp is unmineralized, and hence the answer would be option B, isn't it? The layer of dentine adjacent to the pulp is unmineralized, and hence this is the pre-dentine. So let's go to the next question. This was quite easy, isn't it? Identify the distinct features seen in the ground section below. So again, we are presented with the ground section, and let's see here. We see this is the outer layer. Then we see a tissue here. So this is probably the outermost tissue. This is probably the outermost tissue, and we can see another layer of outermost tissue here. So probably this represents cementum, and this is enamel, and hence this would be dentine, right? And you can see the sigmoid appearance of dentinal tubules here, isn't it? A sigmoid appearance of or a shaped appearance of dentinal tubules. You can clearly appreciate it. So that again endorses the fact that this is dentine, right? Now you can see some dark dentinal tubules in the center, isn't it? These are some dark dentinal tubules in the center. And what are these? These must be dentinal tubules or enamel rods or sclerotic dentine or dead tract. So yes, they are dentinal tubules, but then everything or the majority of the tissue shown in this diagram is dentine. So you have all the tissue that is seen here has dentinal tubules. So dentinal tubules are seen everywhere, right? Dentinal tubules are seen everywhere. But the distinct feature is this central portion, isn't it? The distinct feature is this central portion, and this central portion comprises of dead tracts, right? It is comprises of dead tracts. As you can see, these dentinal tubules appear dark. They appear black, isn't it? So dark dentinal tubules, they are dead tracts. And how are the dead tracts formed? Let's say this is the dentinal tubule which was once open, but due to an acute injury, right? What happened is both of its ends got sealed, and now this has become an empty tubule, isn't it? So this empty tubule appears dark, right? It appears dark on the reflected light. No, sorry, it appears dark on the transmitted light. Right? It appears dark on the transmitted light since it reflects all the light, right? It reflects the light away from it itself. That's why it appears dark on the transmitted light. So though the entire tissue is comprised of dentinal tubules, we will not answer option A, right? We will not choose the option A as correct answer. The distinct feature, that is the central tissue which shows dead tracts, that would be the correct option. Let's go to the next question. Identify the feature marked by the arrows. So identify the feature marked by the arrows. You can see some lines here, isn't it? You can see some lines here. Now looking at the options, cementum, enamel, dentine and incremental lines of Salter, we can clearly say that this tissue definitely is not dentine and it is not enamel, right? So has to be cementum because it is not even bone. So bone nahi hai, enamel nahi hai, dentine nahi. Bacha kya? Cementum. Has to be cementum. So either the answer should be cementum or it should be the incremental lines of Salter. Now what does the question ask about? It asks about the features that are marked by the arrows, isn't it? And the arrows are marking towards these lines, right? The arrow is pointing towards these incremental lines, and hence the answer would be incremental lines of Salter. So these are the incremental lines in the cementum, right? These are the incremental lines in the cementum, and these incremental lines of Salter, they are more regular in acellular cementum, whereas they are irregular in the cellular cementum. Is it clear? They are irregular in cellular, whereas they are regular in acellular cementum. So let's go to the next question. The process in the picture below may be identified as, right? So we have to identify the process that is going on in this diagram, or that we can appreciate in this diagram. So option A, internal resorption, external resorption, cementum repair, and reversal line formation. So when does the reversal line? When there is a resorption, right? And you can see clearly that some sort of resorption has been going on here, isn't it? Some sort of resorption has been going on here, and you can see that the internal tissue here has these line-like structures, isn't it? So probably this is dentine, and then you can appreciate this narrow band of tissue here, right? This narrow band of tissue here which has overgrown in this defect, isn't it? So this is cementum. So it is quite easy to identify, isn't it, from the diagram that the outer layer is cementum and the inner layer is dentine, and resorption has taken place. So what sort of resorption is this? It is external resorption, since it has occurred on the outer surface of the root. So it is external resorption, and the line that separates this resorbed cementum, right, or that demarcates this resorbed cementum from the newly formed resorbed dentine from the newly formed cementum is called the reversal line, isn't it? So reversal line is there, external root resorption is there, and also you can notice that this entire defect is filled, isn't it? So cementum repair has also taken place. So which of the three should be marked? Because we can appreciate all of these three, isn't it? We can appreciate the external root resorption, we can appreciate the reversal line formation, and also we can appreciate the cementum repair, isn't it? So we have to ask which of these three procedures has occurred at the end, or is the last to occur, isn't it? सबसे पहले तो क्या हुआ होगा? External root resorption हुई होगी, isn't it? Resorption would have taken place, and because of this resorption, the base of the resorption, or the demarcation which separates the resorbed lacunae from the dentine, that is called the reversal line formation. So it has formed as a result of external resorption, isn't it? And to counter this, or to heal this resorption, cementum deposition has taken place. So the latest phenomenon that has occurred is the cementum repair, isn't it? The latest phenomenon that has occurred is cementum repair, and which can be endorsed by the fact that cementum can be seen here, isn't it? Cementum formed can be seen filling this lacunae, isn't it? So that is the latest occurrence that has happened here. That is the latest process. Hence, this will be our answer. Clear है? तो हमारा आंसर यहाँ पर सीमेंटम रिपेयर क्यों है? क्योंकि वो लास्ट में हुआ है प्रोसेस, लेटेस्ट प्रोसेस वही है. So that is why our answer would be cementum repair. Though option B, C, D, all three are correct. All these three processes can be appreciated in this diagram. External resorption हुआ है, yes, that can be appreciated. Reversal line formation हुई है, that too can be appreciated. Cementum repair हुई है, that too can be appreciated. The latest amongst these three is option C, and hence that is the better option. क्लियर? तो जैसा कि मैंने पहले ही बताया, सभी ऑप्शंस गलत हो जरूरी नहीं, सभी ऑप्शन सही हो जरूरी नहीं, राइट? आगे बढ़ते हैं. Identify the orthokeratinized epithelium, right? So we know that there are three types of epithelium: orthokeratinized, parakeratinized, and non-keratinized, right? So what's the difference between the three? In orthokeratinized, the outermost layer, that is the stratum corneum, right? It does not have any intercellular, it does not have any organelle or any intercellular structure, right? So the difference between parakeratinized and orthokeratinized is that parakeratinized would also have stratum granulosum, which can be appreciated in orthokeratinized, but it also has nucleus in the stratum corneum, or in the outermost layer. So the outermost layer will display nucleus, isn't it? The outermost layer of cell will display nucleus, and this nucleus is absent in the orthokeratinized epithelium. So with the help of this nucleus in the outermost layer, you can differentiate between the parakeratinized and orthokeratinized, since both of these will have stratum granulosum. So stratum granulosum जो है, that would help you in differentiating between keratinized and non-keratinized epithelium. So here you can appreciate the non-keratinized epithelium in this diagram. In this diagram, you can appreciate the non-keratinized, right? Non-keratinized epithelium. You can see there is no stratum granulosum and nucleus are present even in the cells of the outermost layer, right? So the nucleus are present in the cells of the outermost layer. So this is the non-keratinized epithelium. Presence of nucleus, absence of stratum granulosum. Whereas in these two diagrams, you can notice that stratum granulosum is present in both of these, but nucleus is present in diagram B, the outermost layer. So the diagram B represents parakeratinized, whereas diagram A represents orthokeratinized. Is it clear? Let's go to the next question. Identify the tissue seen in the picture below. So you can see a tissue which has 4 distinct zones, isn't it? It has 4 distinct zones. The outermost layer, it appears almost fibrous. Here it has small cells. Here you can appreciate large cells. And here if you look closely, you will be able to appreciate bone for bone formation. Right? You will be able to appreciate bone formation. So this all information we can get from this diagram. Now let's go to the options. Option A is intra-articular disc. Option B, fibrocartilage on the condyle. Option C is non-keratinized epithelium. Option D is endochondral bone. So we can easily rule out the epithelium part, isn't it? Epithelium to ye nahi hai, because we can see 4 different zones here. In case of epithelium, we have 4 different zones like basal, spinosum, annulosum, and stratum corneum. And if it is non-keratinized, then we have stratum basal, then stratum spinosum, stratum intermedium, and stratum superficial. But this tissue does not resemble the epithelium. You can see 4 distinct zones, which is not clearly appreciable in the epithelial histologic section. We have just seen it, isn't it? We cannot appreciate 4 clear different histologic zones. Where non-keratinized epithelium can be easily ruled out. Also, intra-articular disc can also be ruled out, since the intra-articular disc does not have bone in it, isn't it? It is fibrous disc. It does not have bone in it. On very rare occasions, when it undergoes severe stresses, only there bone formation may be seen, right? और cartilage formation सबसे पहले दिखेगा. Cartilage के बाद बहुत ही rare cases में bone formation दिख सकता है. So intra-articular disc can also be ruled out. So we are left with fibrocartilage on condyle and endochondral bone formation. So if we choose endochondral bone formation, it implies that in this entire thickness, bone formation has to be there. But bone formation is seen only in the lowermost region, isn't it? So endochondral bone formation is seen, but only in the lowermost region. Whereas this entire tissue represents the fibrocartilage on the condyle. So outermost is the fibrous layer, then the layer of the chondroblastic layer, then we have the zone of hypertrophy, and then we have the zone of calcification. So the 4 different zones of the fibrocartilage can be clearly appreciated in this diagram, right? So you can see in the third zone, the chondroblasts have undergone hypertrophy and now they are chondrocytes. So this is the only tissue where cyte cell is larger than the blast cell. Otherwise, you would notice that osteocytes are smaller than osteoblasts, isn't it? Cementocytes are smaller than cementoblasts. But chondrocytes are larger than chondroblasts. The chondrocytes here are larger than chondroblasts. So the next question is mucus versus serous gland. So more than question is it is more of an information, isn't it? So we can see 2 diagrams here, 2 histologic sections here. One is mucus gland and the other one is a serous gland. So can you differentiate between the two? Can you identify which one is the serous gland and which one is the mucus gland? So take a closer look at the first picture. You can appreciate in the first picture, we can see some spaces here, right? I'll mark it in red. Some spaces here between these cells. So intercellular space is more or less visible in this first one, whereas in the second you'll see that no such intercellular space can be appreciated, right? No such intercellular space can be appreciated. Next, you can appreciate that the cytoplasm in the first diagram can be seen to have some granules, right? Let me mark these granules in blue. Though they appear eosinophilic, I'll still mark them in blue so you can better appreciate it. Contrast हो जाएगा थोड़ा, है ना? तो यहाँ पर क्या दिख रहा है अपने को? बहुत सारे granules दिख रहे हैं, right? The cytoplasm appears granular. But what about the figure 2? Here the cytoplasm appears almost empty. It appears almost clear. यहाँ पर cytoplasm कैसा दिख रहा है? Clear दिख रहा है. यहाँ granular दिख रहा है. Right? So there is a difference in the appearance of the cytoplasm. Now let's take a look at the nucleus. What about the nucleus? You can appreciate that the nucleus here appears round, right? The nucleus more or less appears round. Now what about the nucleus in the second diagram? You can appreciate that the nucleus here is flattened, right? The nucleus appears flattened and pushed towards the base of the cell, isn't it? It is flattened and it is pushed towards the base of the cell. So these are some gross differences that you can notice between these two diagrams. Now what we already know is that in a mucus cell, what happens is the entire cell is filled with mucin, isn't it? And this mucin pushes the cell outward. The cell membrane is pushed outwards. Also, the nucleus is also under pressure. So it will be compressed towards the base and it will appear flattened. So all these features can be appreciated in the second diagram. Whereas what happens with the serous gland? In the serous gland, we have a round nucleus and we have zymogen granules in it, isn't it? Close to the apex. These zymogen granules are nothing but the transport vesicles which are packed with proteins, isn't it? So these granules can be seen here. Round nucleus can be seen here, and since the cell does not have any internal pressure, intercellular space can be seen. So even intercellular space can be appreciated here, isn't it? Intercellular space can be appreciated, zymogen granules, and the difference in nucleus. So all these three will help you differentiate between mucus and serous glands. So this is serous, and the second one is mucus. Clear? Let's go to the next question. Question 16. Identify the stage of the tooth development. So, how do we identify the stage of the tooth development? First of all, there are three stages, isn't it? Bud, cap, and bell. This bell can be further divided into early and advanced. Advanced कहो या late कहो, एक ही बात है, right? So, what all can you appreciate in this diagram? First of all, look at the shape of this enamel organ. The shape almost appears like a bell, isn't it? Next, you can appreciate this red zone here, isn't it? And this blue zone beneath this red zone. So these blue and red zones, what they represent? They represent formation of hard tissue. So hard tissue formation is seen and a bell-shaped enamel organ is seen, which makes this as a advanced bell stage. Which makes it the advanced bell stage. So this is the advanced bell stage, isn't it? Formation of hard tissue is already seen. Next is, which of the following diagrammatic representations is a theory proposed to explain dentine hypersensitivity? Clear? So what does the question ask? It asks about which of the following represents a theory which is proposed to explain dentine hypersensitivity. Now let's take a look at the first diagram. What we can see here is there is liquid, isn't it? There is liquid filled in the tubule and arrows represent the outward force or any irritation or chemical, mechanical, whatever it is, right? So this stimulus travels through the fluid and then is perceived by it causes movement of the fluid and is perceived by the neurons. So probably this represents the hydrodynamic theory, isn't it? The first diagram represents the hydrodynamic theory. In the second diagram, you can see that the odontoblast odontoblastic process is seen to extend towards the end, isn't it? So what it says is that the impulse is conducted by the odontoblastic process, and from here it is picked up by the neuron. So second diagram represents the transduction theory, whereas the third diagram shows that this nerve is traveling towards the DEJ, or it extends towards the DEJ. So probably the impulse is directly carried by the nerve. So it is the direct neural stimulation theory, isn't it? So all the three theories are represented here by the means of diagram. So what are the options? Option A, option B, option C, and option D says all of the above. So what would be your answer? Once again, take a look at the question. Which of the following diagrammatic representations is a theory proposed to explain dentine hypersensitivity? Now the question is not asking which of these is the correct theory or the most accepted theory. It is simply asking which of these are the theories proposed to explain the dentinal hypersensitivity, isn't it? So all these theories were presented to explain dentinal hypersensitivity. Whether they were accepted or not is not the matter or is not the concern of this question, isn't it? The question is not asking about which is accepted and which is rejected. It is simply asking which were proposed. That's it. तो इसमें बस ये है कि कौन सी थियरीज प्रपोज की गई डेंटिनल हाइपरसेंसिटिविटी को एक्सप्लेन करने के लिए. तो तीनों ही थियरीज को डेंटिनल हाइपरसेंसिटिविटी को एक्सप्लेन करने के लिए प्रपोज किया गया, एंड हेंस द आंसर वुड बी डी, isn't it? सो लेट्स गो टू द नेक्स्ट क्वेश्चन. तो हमेशा क्वेश्चन को भी ढंग से पढ़ें. कई बार क्या होता है, हमें लगता है कि ठीक है हाइड्रोडायनामिक थ्योरी है या इसी तरीके का कोई और क्वेश्चन आया, हमें लगता है कि यस this has to be the correct answer, and we simply mark that answer, and it turns out to be the wrong option, isn't it? So let's go to the next question. The ground section of the root surface of an old tooth was observed under microscope. It appeared as shown in the picture below. Identify the direction pointed by the arrow. तो ये रूट सरफेस का हिस्टोलॉजिकल सेक्शन है जो कि हम माइक्रोस्कोप में देख रहे हैं, और ये एरो है. तो हमें बताना है कि एरो की डायरेक्शन किस तरफ है. Option A towards pulp, option B towards root surface, option C towards crown, and option D towards apex. तो ये कैसे पता चलेगा? How to find out which direction it is facing towards? So maybe these will help us, isn't it? So what do you see in this diagram? So obviously this surface, it probably is cementum. रूट सरफेस की बात कर रहे हैं, तो रूट सरफेस पे क्या होता है? सीमेंटम होता है. So probably this tissue is cementum. And which cell are associated with cementum? Cementoblasts or cementocytes. If it is a forming cementum, then cementoblast. And if it is the cells that are trapped within the cementum, that has to be cementocytes. तो हमने क्लास में पढ़ा है that cementocytes are trapped in the lacunae within the cementum, isn't it? And they give out processes towards the periodontal ligament surface. Why? Because those blood vessels are very close to these trapped cementocytes, isn't it? So trapped cementocyte hai, they need nutrition, and for this nutrition they will extend their processes towards the periodontal ligament, isn't it? तो ये किस तरफ एक्सटेंड करेंगे? PDL की तरफ, isn't it? The processes are extending towards PDL. So what direction does it become? Pulp तो नहीं है, crown भी नहीं है, apex भी नहीं है, तो आंसर क्या हो गया? Towards the root surface, isn't it? The answer would be towards the root surface, since these processes are extending towards the periodontal ligament. आगे बढ़ते हैं. Next question. Identify the holes seen in this picture, isn't it? तो ये पिक्चर है, इसके अंदर आपको कुछ होल्स दिखाई दे रहे हैं, दिख रहे हैं ना? So these are the holes that you can appreciate in this picture, right? So what are these holes? Option A nutrient canals है, option B bone resorption है, option C bone socket left by the exfoliation of primary anteriors, and option D gubernacular canal. तो क्या लगता है इनमें से क्या होगा? न्यूट्रिएंट कैनाल्स हो सकती हैं क्या? न्यूट्रिएंट कैनाल्स हो सकती हैं क्या? न्यूट्रिएंट कैनाल्स आर यूजुअली एसोसिएटेड विद द रूट, isn't it? So they are not seen on the palate. ये तो हमको समझ में आ ही रहा है कि maxilla है, isn't it? Maxilla है, isn't it? Palate can be seen. तो पैलेट पे हमें न्यूट्रिएंट कैनाल्स नहीं दिखेंगे, वो तो हमें रूट की तरफ दिखेंगे. इफ वी टेक अ क्रॉस सेक्शन ऑफ द बोन क्लोज टू द टूथ, isn't it? तो वहां पर हमें क्लोज टू द एपेक्स डेफिनेटली न्यूट्रिएंट कैनाल्स कैन बी सीन, बट दे वोंट बी टू लार्ज, isn't it? इतने बड़े बड़े तो नहीं होंगे, बहुत माइन्यूट होंगे, माइक्रोस्कोपिक होंगे, ठीक है? तो न्यूट्रिएंट कैनाल्स तो नहीं है. Bone resorption doesn't look like bone resorption, isn't it? It doesn't look like bone resorption. Then maybe it is the bony socket left by the exfoliation of primary anteriors. क्या ऑप्शन सी सही हो सकता है? क्या ऑप्शन सी सही हो सकता है? Then we have to remember that the anteriors, uh, not the anteriors, that the permanent teeth, they are always on the lingual side of the deciduous anteriors, isn't it? The permanent anteriors are placed or they erupt the lingual side of the deciduous anteriors. So we can appreciate that these holes are on the lingual side of the teeth, whichever are seen in this diagram. तो जो भी दांत है ये दिख रहे हैं डायग्राम में, इसके lingual side में, तो डेफिनेटली लिंगुअल साइड में प्राइमरी तो नहीं हो सकता, परमानेंट डेफिनेटली हो सकता है, प्राइमरी नहीं हो सकता. प्राइमरी हैज टू बी टुवर्ड्स द लेबियल एंड permanent are on the lingual side, isn't it? So even the option C is ruled out. So if you even rule out all the options, you will go to the, you will get the correct answer, isn't it? And the correct answer is gubernacular canals. So जब हम टूथ eruption की theories पढ़ रहे थे, उस वक्त हमने पढ़ा था gubernacular canal and gubernacular theory, isn't it? So initially the primary and the permanent teeth, they both reside within the same bony crypt, isn't it? तो same bony crypt में primary tooth भी है, permanent tooth भी है, but as the child grows and as the tooth grows, this primary tooth will move away from the permanent tooth. Permanent tooth takes longer time to form, isn't it? Primary tooth on the other hand forms relatively quickly, isn't it? तो primary tooth अपनी खुद की bony crypt बनाएगा and this permanent tooth will have its own bony crypt, isn't it? And yet they are both connected. These both bony crypts are connected. And this connection between the bony crypts of primary and permanent is called the gubernacular canal, isn't it? So this gubernacular canal can be seen associated with all the succedaneous teeth. Is it clear? And its role is to help in the eruption of succedaneous teeth. So let's go to the last question. Identify the feature marked by the arrows. Identify the feature marked by the arrows. तो ये arrows दिख रहे हैं आपको और यहाँ पर ये आपको कुछ lines दिख रही हैं and we have to identify this feature what it is. So first let's identify the tissue. Probably you can see a scalloped region here, isn't it? You can see a scalloped region here and enamel rods in the outer tissue. So definitely has to be dentine. The inner tissue has to be dentine, right? Now the options are contour lines of incremental lines, Von-Ebner's lines and Schrager bands. So Schrager bands से शुरू करते हैं. What are Schrager bands? Hunter Schrager bands we have studied in enamel, isn't it? They are the light and dark bands. Optical illusion है या they are formed because of the change in direction of rods. We see the same Schrager bands in dentine also. In dentine, these Schrager bands these Schrager bands form due to the overlap of primary curvature, right? We know that this dentinal tubule has a S-shape or a sigmoid curvature. So you can see this primary curvature, when it overlaps, it forms the Schrager's bands. So in the entire thickness of dentine, only two bands will be seen, one dark and one light. If the secondary dentine has, then maybe you will see two more bands, but these will be narrower as compared to the one in the primary, or maybe they will be broader. Depends on how much secondary dentine has formed, isn't it? But definitely they won't be broader than the primary. Primary dentine का तो ज़्यादा ही होगा. तो dark light, maximum 4 bands दिखेंगे आप, उससे ज़्यादा तो नहीं दिखेंगे. इसमें भी दो बड़े होंगे जो प्राइमरी के हैं और दो छोटे होंगे जो सेकेंडरी के हैं, राइट? यहां पर हमें कितने दिख रहे हैं? 3 बैंड्स दिख रहे हैं and they are all very thin, isn't it? So do you think that these are the Schrager's band? The answer would be no, they are not the Schrager's band. And the next option is Von-Ebner's lines. Von-Ebner's lines are daily increment lines, isn't it? So daily increment lines are seen at a distance of 4 microns and they should be numerous, isn't it? They should be numerous क्योंकि पूरा डेंटिन है तो बहुत सारी दिखनी चाहिए. यहाँ पर तो हमें केवल 3 दिख रही है. That means they are not even Von-Ebner's lines. Von-Ebner's lines भी नहीं है. वन एबनस लाइंस नहीं है तो डेफिनेटली इंक्रीमेंटल लाइंस तो नहीं है. Are these the incremental lines? Because incremental lines include three types of lines. Von Ebner's lines, which are daily lines. Anderson's lines, which are weekly lines or same to stria of ridges that are seen in enamel. And the third one is neonatal line. So neonatal line has to be a single line. Again, this is not neonatal line. तो neonatal line भी नहीं है, Von Ebner's line भी नहीं है, तो incremental line definitely. So what are we left with? We are left with the contour lines of 1. So how are the contour lines of 1 formed? They are formed because of the overlap of secondary curvature of dentinal tubules, isn't it? So dentinal tubules along its entire length has small curvatures, right? It has multiple small curvatures, and when these multiple small curvatures overlap, they will form contour lines of 1, right? So they will appear randomly in dentin because this overlap is not a rule, isn't it? It can happen randomly. So these lines will be seen randomly. And as you can see in this diagram, we just see 3 contour lines of ovens. There are no lines above it, no lines beneath it, isn't it? So the correct answer is contour lines of oven. तो जब भी एमसीक्यू सॉल्व करते हो आप, यू कैन यूज वेरियस टेक्निक्स, इजंट इट? सबसे पहले इंपॉर्टेंट चीज तो यही ध्यान रखनी है हमें कि सारे ऑप्शन सही भी हो सकते हैं, सारे ऑप्शन गलत भी हो सकते हैं. तो अगर सारे ऑप्शन सही हैं तो हमें वो ढूंढना है जो सबसे ज्यादा सही है, सभी गलत हैं तो वो ढूंढना है जो सबसे कम गलत है, राइट? देन वी मस्ट ऑल्सो रिमेंबर दैट वी कैन समटाइम्स अराइव एट आवर आंसर बाय रूलिंग आउट द अदर ऑप्शंस. मेरे ख्याल से वो तो तुम कर ही रहे होगे. रूल आउट करना आसान है ना? रूल आउट कर सकते हो, एंड इफ यू डायरेक्टली नो इट, मे बी डायरेक्टली आंसर इट, राइट? सो देयर आर वेरियस टेक्निक्स, यूज ऑल दोस टेक्निक्स टू सॉल्व द क्वेश्चन, बट नेवर गो फॉर द करेक्ट आंसर. ऐसे एडमेंटली ये नहीं ढूंढना चाहिए कि करेक्ट आंसर ही चाहिए हमको, क्योंकि कई बार ऐसा होगा कि एक ही क्वेश्चन में 3 करेक्ट आंसर होंगे. जैसा हमने वो देखा एक्सटर्नल रिजॉर्प्शन वाला क्वेश्चन, उसमें 3 करेक्ट आंसर थे, इजंट इट? एक्सटर्नल रिजॉर्प्शन भी हो रहा था, रिवर्सल लाइन भी फॉर्म हो रही थी, और सीमेंटम भी फॉर्म, बट वी वेंट विद द सीमेंटम फॉर्मेशन. क्यों? क्योंकि दैट वाज द लेटेस्ट फिनोमिनन, इजंट इट? तो मोर देन वन ऑप्शंस कैन बी करेक्ट. ये हमें ओपन माइंड के साथ चलना चाहिए, right? And we have to look at the circumstances and accordingly we should choose the answer. Clear? So that is all for today. I hope तुमको ये क्लास अच्छी लगी होगी, समझ में आया होगा, and I hope we'll meet again soon. तो अगर कुछ पूछना है तो पूछ सकते हो, अदरवाइज पैकअप करते हैं.